All right. Um, so now we move on to Thomas Kuhn. So my memory is actually wrong because Popper died in 1994 and Kuhn died in 1996. So it wasn't exactly the same time, but I guess it was close. Um, which again is what led my roommate at the time to conjecture that space aliens were trying to conquer us by killing off our leading philosophers of science. Um, all right. So Kuhn was and I guess still is something of an outsider in philosophy. Um, although he's well, at least was, I think still is very popular outside philosophy. um, um, I guess in that way he's like Popper, but more so. Um, all his degrees through his PhD was in 1949. It was in physics. All his degrees were in physics. Um, and he switched to history and philosophy of science on his own, so to speak. Um, although he went on to hold positions in prestigious philosophy departments. First, he was at Berkeley, and then at Princeton, and then at MIT. Um, but I think my impression is that even there, he was never entirely part of the culture of the department. Um, and to this day in philosophy, I think, as opposed to maybe some parts of some of the social sciences or other places, he's regarded more as a kind of problem to be solved, if people think of him at all, uh, than as like a figure to be kind of inherited or followed or something like that. Um, and why that is, I I can't really explain, but at least it seems to me it's not because there isn't something really philosophically interesting here. Um, so why is this book in the Popper half of the course? Um, well, so Kuhn actually says he hadn't read anything by Popper until the English Logics of Scientific Discovery um, appeared in 1959. And this book was finished in 1962. Um, he's, and where does he say this? Uh, oh, it's in the Shilp Popper volume. Um, yeah, he says he hadn't read anything by Popper until 1959, although he had heard him lecture at Harvard in 1950. Um, but by 1959, the Kuhn says the structure of scientific revolutions was already in draft. Um, now, it's clear that the draft was revised after that because the version we have does actually mention Popper and cite the logic of scientific discovery. This is on page 146 to 7. Um, but I guess the point of Kuhn saying that is to indicate that, this book wasn't written in response to Popper's writings directly. Um, however, Kuhn does thank in his acknowledgments, along with my teacher, Stanley Cavell, um, among people he thanks who he was uh, says he was engaged in frequent discussions with when he was at Berkeley was Paul Feyerabend. Paul Feyerabend was a, student and follower of Popper. So, I mean, chances are, between having heard him lecture at Harvard in 1950 and knowing Feyerabend, he actually did know quite a bit about what Popper thought before he wrote this book. Um, um, However, like beyond that, I guess I would say, why it's in that this half of the course. Well, so what is it an attack on? Or at least he's more polite than that, right? I mean, he's a lot more polite than Popper. Um, he's uh, but what is it an attempt to revise, let's say? Well, it's received views about the nature of science, right? That's what he starts out saying. There's these like received views of the nature of science that were part of my education in philosophy. Again, his education in philosophy wasn't mostly through he didn't major in philosophy, but he says he'd been interested in it a long time. And and then he returned to it more seriously after he started working on history of science and encountered various difficulties. So so received views about the nature of science now, but what does that mean here? First of all, like what does the nature of science mean? Well, it's not like received views about what makes something cognitively meaningful as opposed to nonsense, right? That is, it's not received views about what the um, logical positivists, or at least Carnap, are interested in. Um, uh, if you said like, but Kuhn, how does your view apply to graphology? um, which remember, Carnap is perfectly happy to include among the sciences because it's empirical. Is it right? Maybe not, but it's empirical because it uses empirically meaningful concepts. Um, so that is, in principle, it could be translated into sentences about our sense data. At least Carnap is willing to give them the credit that, yeah, we could, although we can't do it yet, we can't do it for any science yet. um, so, uh, Um, it's not about that. Rather, it's about the demarcation between science and other types of human activity. So it's really about Popper's demarcation problem. It's that he's responding to. And it's about Popper's, or it's about methodology, the methodology of that, science in particular. Science properly speaking, not just anything that has some empirical meaning. And he says, this is from page 2, and at this point, I think he's agreeing with Popper. At least Popper will agree with this um, to a great extent. Um, Remember how Lakatos talks about views that turned out to be false being buried with military honors, right? That's how he describes Popper's view about falsified theories. They were science, but they've been falsified. So, so anyway, this is what Kuhn says on page 2. If these out-of-date beliefs are to be called myths, and he's talking about things like um, the phlogiston theory. So this is something that's going to come up again. One of Kuhn's main examples, right? They um, the explanation of a range of things that we explain by means of oxygen were before Lavoisier explained in terms of something called phlogiston. And phlogiston, so for example, metals were supposed to be compounds of earth and phlogiston. So this is the opposite of what we think. We think the quote unquote earth is an oxide of the metal, but they thought the uh, metal was a combination of what we call the oxide and phlogiston. And when you burn things, they thought they give off phlogiston. Um, and um, so this is something that Kuhn says people with a cumulative view of science, right? Like that the history of science is at such and such time they discovered this, and then they discovered this, and then they discovered this, and then they discovered this. Um, don't have any space for something like the phlogiston theory, right? You can't ask when did they discover phlogiston because there is no phlogiston, according to us. And so they dismiss that as an error. They were doing something wrong, and that's why they thought this stupid thing. But I think Popper and Kuhn are on the other side of that. So let me finish reading the sentence that I just started. If these out-of-date beliefs are to be called myths, then myths can be produced by the same sort of methods and held for the same sort of reasons that now lead to scientific knowledge. If, on the other hand, they are to be called science, then science has included bodies of belief quite incompatible with the ones we hold today. Given these alternatives, the historian must choose the latter. Right? So the point is, um, uh, what uh, makes science science is not is first of all not just being meaningful, right? We're talking about something much narrower than that. And second of all, is not like discovering truths that we still think are true. Rather, it's something like a certain methodology, right? These out-of-date beliefs were produced by the same sorts of methods and held for the same sorts of reasons that now lead to scientific knowledge. Um, so, I mean, so far he's talking about the same thing as Popper and not talking about exactly the same thing as Carnap or Quine or Goodman. Um, he's only interested in mature sciences, as he says. Um, on the other hand, the thing he's going to say that's surprising is particularly a problem for Popper. Well, okay, so I guess it depends what you think he says, what you think is surprising in what he says. Um, and what I want to say about that is this book is called The Structure of Scientific Revolutions. So you might think the most surprising thing it has to say, the central thing it has to say is about revolutions. But before getting to the part about revolutions, um, you have to get past what he says about so-called normal science. Normal science is science between revolutions. And what he says about normal science is that it looks like an attempt to stuff nature into preconceived boxes, right? The scientists are doing whatever they can to make certain concepts apply to the world, essentially. That's what those boxes are. Um, so, from Carnap's point of view, that's not so bad, right? I mean, what makes science scientific is that it uses legitimate concepts, empirical concepts. So, sure, as long as your concepts are good, you can try to stuff nature into them. Um, oh, I see Josephine has been saying something. What is the falsification hypothesis for the space aliens claim? All right, never mind that. Uh, I don't think that was intended to be a scientific theory um, when he said that. Um, so, um, but from Popper's point of view, it shouldn't matter what concepts you use. What makes scientific theories scientific is not the concepts they use. Remember that, like, the negation of a basic statement may not be a basic statement. It may be metaphysical and unfalsifiable. So the negation of a statement definitely includes exactly the same concepts as the statement itself, right? If the statement is, A is B, and these are the concepts, A and B, then the negation has the same concepts in it. So according to Popper, it's not what concepts you use, it's um, um, whether you're risking something by making this statement. And for example, many times the in the negation you aren't risking something. It can't be falsified, whereas in the positive one you can, or vice versa. Um, so for Popper's point of view, the idea that scientists are stuck with certain concepts and they try to do whatever they can to make those concepts apply looks like the opposite of what he says we should be doing. Okay, so I mean, that's just a general background to why I put this in this part of the course rather than the other part of the course. I mean, obviously, we'll get into more details about Kuhn, and I hope it'll become clearer why what Kuhn says is such a problem for Popperians in particular, and why the main problem is normal science. Um, okay, so before getting into the details, though, there's one other thing a big question I want to discuss about Kuhn, or a general question about Kuhn, and that um, is his theory or whatever it is, I mean, I don't know if we should call it a theory, but is what he's saying here meant to apply to his own field? That is, when whatever his own field is, history of science, philosophy of science, something in between. Um, so I mean, because remember, Popper said that at least in the precise form that yields the demarcation criterion, his view is not supposed to apply to what he's doing. Um, what he's doing is methodology, not science. So what about Kuhn? Well, I mean, um, we'll have more basis for discussing that later, but I want to flag it to keep in mind because the answer is it's confusing. And it might make a big difference whether he intends this to apply to what he's doing or not. So, I mean, because we'll see that sometimes he at least strongly hints that it is meant to apply to what he's doing, right? That like what he's doing is part of a certain revolution of exactly the kind that he talks about. Um, But on the other hand, there's also good reasons to think that it shouldn't apply to what he's doing because those fields, history and philosophy of science, don't seem to be what Kuhn would call mature sciences at all. They don't display the characteristics that he thinks are special to mature sciences. Um, So, unless maybe he wants to claim that his is going to be the first paradigm, and now we're going to have a mature science, um, that uh, that doesn't seem to fit. So it's again, it's confusing what he means about that, and we'll just have to keep that in mind. All right. Um, are there questions about Kuhn in general before I get into the details? Okay. There's not that many people here, but among the people who are here are the people who usually ask questions, so there could be questions. All right. Um, okay, so the old picture that he's fighting against, what he calls the image of science, which has us in its grip. So that's an allusion to Wittgenstein, um, to the later Wittgenstein. Um, and Kuhn is definitely influenced in some ways by the later Wittgenstein, both directly and because he was so close to Stanley Cavell, as actually they both note in the introductions to their respective main works. At this time, they were very close to each other, and Wittgenstein is like the most important philosopher for Cavell. So, however, I'm not sure that Kuhn has a really broad or deep engagement with Wittgenstein. There's certain things he takes from Wittgenstein. So anyway, so here's this image that of science in whose grip we are. And the image is development by accumulation. So the old picture, let me erase this. I mean, I already mentioned this because I started talking about phlogiston and whatever, but um, and here, we should understand this in specifically in the sense that Popper imagines inductivists defending it. Now, I mean, do the actual inductivists, I mean, that is the inductivists that we've read, which means, uh, well, Carnap and Goodman, at least, certainly. Um, do the actual inductivists that we've read imagine exactly this picture? Probably not, I would guess. But these are the inductivists or justificationists that Popper imagines. And so remember what they think is that um, the development of science is necessary in the absence of empirical catastrophe, right? The progress of science is necessary and steady because it just depends on more data coming in. So the more data we have, um, the better we can confirm our theories were developed from the data, and as the data come in, more data come in, they either serve to confirm our old theories completely or to show that they're merely special cases of more general theories and perhaps only approximately right. And right. Um, so uh, and um, um, And in fact, if we had been careful about how we stated them before, we wouldn't have to give anything up in those cases. Um, right, Kuhn is going to be a little bit more explicit about this assumption when he discusses it later than Popper is, that, the way this works, and these are the people that Kuhn is going to call positivists. The way this works is they say, well, um, you should have said only things that were supported by the data. So, like when you said between any two masses, there's an attractive force, inversely proportionate to the distance between them, and et cetera, et cetera. You should have said, in the type of cases we've seen so far, to the limits of accuracy that we've measured it, it's true that, or apparently true that, between any two masses, there's a retractive force, etc. Right? If you had said it that way, then that's still true, right? Like that hasn't been shown to be false. And it couldn't be shown to be false again unless the world just suddenly started behaving differently than it ever did before, and that doesn't happen. Um, it's right. So in other words, that we observed the exact same setup twice, and there wasn't some other factor we didn't know about. Or I mean, maybe not twice, but like 100 times, and it behaved one way, and then all of a sudden, from then on, it behaved the opposite way. Um, right. So that doesn't happen. Why we should believe that, I don't know, but we don't expect that to happen. It's never happened yet. And so, so like if we were only careful, there would be pure accumulation in the history of science. At a given time, more data would come in, and that would allow us to discover more stuff that we didn't know before. Um, and even, let's say, Ptolemaic astronomy um, would like actually have been um, confirmed and extended by new data, because all the Ptolemaic astronomers should have said is, from where we stand on the Earth, it looks like the planets are moving around the Earth in such and such a path. And that's true, right? If they had been careful enough. So that's the old image. And then it's from this point of view that you say, well, and if you look back in history and you see that someone believes something that um, um, isn't preserved in our current theories, like they believe in phlogiston, and our current theory has no room for phlogiston. There's no such thing as phlogiston. So you say um, something like, well, of course, they observed some real phenomena. And for that reason, some of the things they said are still valuable. But they were just completely inventing a myth when they attributed it to phlogiston. Right. So I guess, I mean, it's similar to what you would say about the Ptolemaic astronomers' epicycles in the version that I was just giving, right? Where So one of Ptolemy's innovations, and this completely violates Aristotelian physics, by the way. So like Ptolemaic astronomy was never in accord with Aristotelian physics, right? Because according to Aristotle, everything either in the sublunary world, everything either naturally moves towards the center or away from the center. And in the superlunary world, everything moves in a circle around the center. But Ptolemy, to account for the way the planets actually move in the sky, um, described their path as a circle moving around another circle. So this circle is turning one way and the other circle is turning the other way. And that's why, you know, You've heard the expression Mercury is in retrograde, right? Like people are having bad luck today because Mercury is in retrograde. Mercury is in retrograde means Mercury is going the wrong direction in the sky, right? So, like if Mercury were actually moving on a circle around the Earth, you couldn't explain that. It would always go in the same direction. But in fact, the planets sometimes turn around and go back in the other direction. Now, I mean, why is that really, according to us? It's because um, um, how does it go this way? Mercury is going faster than the Earth because it's nearer the sun. So sometimes it catches up with us. Wait, is that why? No, that's why for the outer planets. For Mercury, it's because sometimes we see it going back that way. Right. So, but Ptolemy, in order to explain this, said, "Oh, put another circle here." That's called an epicycle. And eventually, people tried to make it more accurate by adding more epicycles. um, so, uh, um, Right. So what we would say from this, what Kuhn calls positivist point of view, we would say, well, the Ptolemaic astronomers' observations are good. When they introduced these circles to explain them, that was just a myth. They shouldn't have talked about that. And um, Kuhn says it can't be because uh, once again, he says the methods and reasons which led to those supposed errors and myths are the same ones that have led to current scientific knowledge. So, um, unless you're willing to say oxygen is a myth, then you shouldn't say phlogiston was a myth. Um, okay, so we reject that cumulative view. Now, I mean, remember, Popper actually tries to explain why the history of science is kind of cumulative, even though his view doesn't seem to predict that, right? And then he had that thing about quasi induction. Um, but um, but Kuhn is saying actually there's nothing to explain here because the history of science is not cumulative. um, so it involves replacing an older theory with an incompatible theory. They can't both be true. And in particular, therefore, one is not a special case of the other one. Okay, so you might think then that we would move to Popper's answer, and that quote I read from page 2 makes it sound almost like Kuhn is going to do that, right? When he says it's the same methods and reasons, so you think, oh, okay, so the demarcation problem is going to be solved by methodology. We're going to say not that um, certain things were scientific because they contributed to the sum of knowledge that we have now, but that they were scientific, certain activities were scientific because they used the right method. And that's Popper's answer. Um, but Kuhn also rejects that alternative answer. And I think the first thing is really important is to understand why. Um, So, first of all, he points out that what characterizes the mature sciences as opposed to immature sciences. Now, I mean, this way of talking was and thinking was like very widespread at this time. I think Popper thinks this way. I think Carnap and Quine are not very interested in it, but probably would. I mean, I think they also subscribe to it. They're not very interested in it because they think the problems of the so-called immature sciences have been solved in principle, right? Like, yeah, it's too hard to do now, but of course, there's some way of reducing it to sense data or whatever, right? So, again, that's why Carnap is so happy to let in any kind of random discipline, as long as it doesn't, as long as they don't say, no, we're not empirical. Carnap is like, okay, I will try to fit you into the constitutional or constructional system. Um, um, So anyway, I sorry, that was all like a big parenthesis that that way of thinking that there's that the I guess what we might call, to use a more neutral term, the hard sciences or the physical sciences and to some extent the biological sciences, right? Or something like that. Um, that those sciences are different from other science-like things just because they're more mature, meaning that the other ones will be like them later, right? So that someday psychology and sociology will be like physics, right? And that's why Kuhn says, since prehistory, one after another has crossed this threshold and become a mature science. Um, all right. So, and what he points out is that what characterizes these mature sciences is consensus. Consensus about something or other, or rather about a lot of things. First of all, consensus about fundamental theories. I mean, that's the easiest one to understand. Um, and Kuhn himself in later writings seems to accede to this and say that, you know, yeah, what's really important is the theory. But uh, in this book, and I think that's the more interesting view, is in this book, he always emphasizes that theory isn't all there is to it, right? But at least we can begin with fundamental theories, right? So Kuhn says, like in physics, everyone pretty much agrees on the fundamental theories. Um, So they don't spend any time arguing with each other about them. They take for granted that everyone agrees. The audience they're writing to agrees about them with on, um, both on a kind of metaphysical level, like what kind of things there are in the world or whatever, but also more specifically on physical theories. Um, so, and therefore, the things they work on are much narrower and more specialized. They're not spending time um, re like everyone trying to rebuild the science from the foundations. Remember, that was also something that Carnap emphasized about science, as opposed to philosophy, in the preface to the Aufbau. That become by becoming more like scientists, we were gonna get to a point where everyone could contribute one little piece at a time, and we could go, forward, as opposed to like everyone trying to set up their own system. So Kuhn says, yeah, and that's the difference. Like if you look at now, I mean, his division between mature and immature science is not the same as the division I would make between modern science and like Aristotelian science, for example, right? Like he includes Aristotelian physics as a mature science. I, we're looking at different things, I guess, as characteristic. So, but yeah, so from his point of view, um, This was true of Aristotelian physicists, like already in antiquity, or it's true of mathematicians, astronomers. Um, but then you see, well, actually, no, maybe he doesn't think it's true of physicists. I take that back. He thinks it's true of astronomers and mathematicians in antiquity. That they're not there aren't different schools, each with its own system, arguing with each other about fundamentals. Um, they're just all taking for granted a certain theory and working out special applications of it or something like that. Whereas other things like philosophy and the current social sciences, um, we find the pattern is that there's lots of disputing schools, and that people, as Kuhn puts it, have spend more time addressing the members of the other schools than addressing nature. Right? So they're arguing about fundamentals with the other schools. And that's why they don't make any progress, because they're always going back to the beginning. Remember, I said that about logical positivism, that although Carnap and Neurath predicted this period when it was they were going to not have to worry about fundamental issues anymore, and they would just go on to the positive program of constructing the system of science or whatever, that never actually happened. The entire history of logical positivism is it was still what Kuhn would call an immature science, right? They just kept going back again and again to the question of what is the verification criterion of meaning, what are, observations, etc. Um, okay, so the mature sciences are characterized by a consensus about theory, but also the consensus about lots of other things like experimental methods, equipment, even Kuhn includes in this, right? Like everyone knows that a certain kind of equipment is useful in answering a certain question. You don't have to go back and demonstrate that. Um, uh, um, but more broadly, everyone knows that certain techniques are useful for testing certain things. You don't have to go back and argue about that. So, like I said, for Carnap, I think Carnap thinks this is a positive feature of science and even thinks he can explain it. But as for Popper, it's actually not that easy to explain why, quote unquote, mature science should be like this. I mean, Popper doesn't exactly explain why is the decision to accept a theory or a basic statement not just a personal decision? Right? I mean, falsifiability, so like I could propose my own theory, accept it, and then decide what basic statements to accept. And based on that, I could decide whether to give up my theory. Um, or to put it differently, Popper, I mean, because I guess you can see why that would be maybe not as useful. Not as useful for what? Not as useful for getting at deeper and deeper questions about the world, as Popper sometimes puts it, something like that. Um, but um, but even if you can see that it would be kind of useful, Popper doesn't discuss the political structure that is needed to ensure that it happens, that it isn't merely personal, right? Because that's like a coordination problem, right? Like even if we all agree that it would be better if we all accept the same theory and the same basic statements, and then, there's more of us to do the testing or whatever. Uh, how do we decide which theory to accept? Um, so Lakatosh, um, in his kind of rephrasing of the criterion of demarcation, says something like, there are situations in which scientists will unanimously agree that a certain falsifying hypothesis has been corroborated, etc. Right? Sometimes Lakatos calls it the jury of scientists, um, building off Popper's own metaphor of jury, trial by jury. The jury of scientists is unanimously agrees. Um, okay, but like, why does that happen so often? And that's where Lakatos slips in, or if the agreement isn't unanimous, we can declare those who disagree to be cranks. So that is, uh, this would be like trial by jury, except that somehow if one person refused to follow the rest of the jury, the other people could like read them out. um, so, um, but like I said, Popper doesn't discuss, and it doesn't seem to be friendly to his view of science to introduce this. He doesn't discuss what kind of mechanisms are going to be necessary to create this consensus. Um, and Kuhn says this is what makes the question especially pressing. This is on page 3. Um, no, I can't find it. But anyway, I'll read it from my notes. The insufficiency of methodological directives by themselves to dictate a unique substantive conclusion to many sorts of scientific questions. I guess that's not a sentence, but it's a sentence fragment. But he says there is an insufficiency, right? Methodological directives by themselves are not sufficient to dictate a unique substantive conclusion. Now, I mean, again, like if you were to aim this against Popper directly, this would be another version of the there's no algorithm objection, right? That is, the methodological directives can't settle a unique answer means um, the same thing as what Putnam means when he says there's no algorithm for this. Um, um, so, so Popper could respond, well, I never said that. I never said there was an algorithm. Um, that is, Popper agrees that the correct methodology alone doesn't lead to consensus. We have to guess. And again, somehow we have to agree what to guess. And I guess we would have to agree what to guess because we all believe in the method. Um, okay. As I'm talking, I'm getting these things into a different order than I have in my notes, which is confusing me. Possibly a better order, but it's confusing me. Um, because I kind of talked about this, like I kind of just talked about the same thing twice, but right, that is, um, Popper can agree with Kuhn that there's no algorithm for doing this, but Popper doesn't, unlike Lakatosh, um, seem to think that we should have a kind of oppressive political structure to make it happen. Um, so we don't have a really good explanation of why it happens from Popper's point of view. Okay, so in other words, um, um, if the scientists like so on the accumulation view, we can say the reason there's consensus in the mature sciences is because the scientists all agree on something that has been shown to be true by the data. But we don't believe that. And then you might think you could say, well, they all agree because they have a methodology. But actually, even Popper doesn't believe that. So why do they all agree? Because it's so striking, right? That's such a striking difference between the very sciences that we're trying to understand the success of and everything else. And to explain Kuhn's explanation for that is what he calls paradigm, having a paradigm. Right. So to summarize everything that I just said with lots of like um, uh, digressions and whatever, um, it's that um, um, the accumulation view isn't right. The methodology view doesn't explain the consensus either. And therefore, we have to introduce something else to explain the consensus, and that is what Kuhn calls a paradigm. So this is, I mean, that the although the term is introduced later in the book, the idea is introduced already on pages 4 to 5. Um, and so let me now try to explain what that is, because obviously that's one of the most important questions in understanding this book. What is a paradigm? Um, and it's notoriously problematic. The meaning of the term paradigm in Kuhn is notoriously problematic. I mean, first of all, I guess you should know that it's Kuhn is the first one using the term paradigm in this sense, right? I mean, a paradigm is a pattern. Um, uh, the ancient Neoplatonists said that the forms are paradigmatic causes. They added that to Aristotle's four causes. The paradigmatic cause, right? They cause things by being the pattern after which it is fashioned or towards which it aims or something like that. Or both, I guess, according to ancient Neoplatonists. Um, and, there's various other uses of paradigm like that in grammar and whatever. But, when someone says we need a new paradigm, it's time for a paradigm shift, right? That all comes from this book. So he's introducing this term. And yet it's notoriously difficult to figure out what he means by it. Now, I mean, you should be suspicious of notorious things like that. Like a lot of times it's notorious that philosopher X has a problem with Y, and when you actually read philosopher X, you're like, no, not really. But in this case, at least, Kuhn himself does say in the postscript, right? So this edition has in it the postscript that from 1969, where Kuhn modifies some of the things he says, commented on some of the things he said. Um, and in the postscript, Kuhn himself says that he used the term in two entirely different ways in the book. So the two different ways he mentions um, are, and I think they're, when he says they're entirely different, I mean, um, it's kind of like Carnap's type ambiguity here. They're about the same thing, but they're at different levels or something like that. So he says, first of all, he uses it in a sociological meaning. Sociological meaning. And in the sociological meaning, it means something like the whole framework of assumptions and procedures and so forth that characterize a research tradition. Um, and usually when he talks about giving up the old paradigm and adopting a new paradigm, a lot of times he's thinking about something like that. But it also means an exemplary achievement. Um, so an exemplary achievement, like for example, Newton's Principia. Um, um, and this is how why he started using the term paradigm for it. Newton's Principia becomes a paradigm of how to do physics, right? That's the pattern that you follow. Um, and um, as he says later on in, I guess, chapter 3 or chapter 4, one of those chapters, it's like oftentimes the various people actually um, don't exactly agree on what aspects of that paradigm achievement are the relevant ones. Right? Like when that is when you abstract from the particular example and say, what do we learn from this? That apply it to our own research. Different people in the field may actually um, um, not be doing that the same way. But having that common paradigm in this sense of an exemplary achievement can be enough to keep them um, from splitting into schools and disputing and all that stuff. Because it just covers over the ways they may disagree with each other until they run into trouble. And then it comes to light that actually no one ever understood it exactly the same way. So, I mean, uh, that is to say, in this book, Kuhn argues that this kind of exemplary achievement is central to this sociological structure, right? Like it's one of the things that keeps it together. Now, he says nowadays, and this is a little harder to fit into the picture I just drew, or certainly to the use of the term paradigm. Kuhn says nowadays the role that was taken up by these like single books by important people or something like that is instead fulfilled by textbooks. So rather than going back to the classic writings of Newton or Einstein or whatever, um, you have a textbook that's dressed it up in the way we now talk about it, and it's easier to follow. And actually, like in the case of Newton, present physicists would need special training probably to read it. Um, so, um, so somehow the exemplary achievement is it's a much more abstract entity now. It's not a particular book. It's a particular way of writing textbooks or something like that. The type of problem sets they contain, the type of examples they use. That's the pattern. And but again, it has that same characteristic that as long as everyone agrees on that, they can go along fine, even though they don't all understand it exactly the same way. Um, Okay, so we have this paradigm in one or another of these senses, and a lot of people say it has more senses than just that. And Kuhn, it's used for a lot of different things, although they all circle around the same issue. How is it that a mature science achieves consensus? And the important thing about a paradigm in achieving consensus is Kuhn says the paradigm is rigid. The paradigm um, serves to narrow the vision of scientists who are trained by it. Um, um, that is, uh, scientists accept it without question most of the time. In fact, they don't even necessarily think about it because they've been the training in the paradigm has trained them to consider certain questions interesting um, or practical to approach, relevant, certain techniques, again, like experimental methods, forms of equipment, whatever. The training in the paradigm has led them to um, accept that this is the way you do whatever their field is. And when we say whatever their field is, Kuhn always thinks that there are like both broader and narrower paradigms, right? So that as he puts it, like some specialty can be overturned by a revolution in something that from the broader point of view of the physical sciences, let's say, looks minor. One of the examples he's going to discuss later is the discovery of X-rays and how for certain practitioners that was a revolution, even though for physics as a whole it was just like, oh yeah, there's one more kind of radiation. um, right. Um, Now, obviously, that's in direct confrontation with Popper, right? I mean, if you say scientists achieve their success because they have a theory that they've been trained not to question, that's the opposite of how Popper thinks we should relate to our theories. And what leads Kuhn to say this? Um, well, it's complicated, but part of it is um, that he says, and it's related to what I was just saying about how they can agree on the paradigm while disagreeing about other things, is that it's easier to determine the paradigm than it is to, and it's easy to determine the paradigm. Now, I mean, now it's, does he mean this or this? But anyway, I guess at this point he means this. It's easy to find the paradigm, but it's going to have to be, at least for us, and also maybe for a lot of these subfields or whatever, it's not going to be a book I can show you. It's going to be something a lot vaguer than that. But still, it's easy to find the paradigm, or I guess maybe you should say it's easy to find things that belong to the paradigm, theories, methods, etc. It's difficult to find the rules that scientists are following. And why is that? This is on page 47. Um, though many scientists talk easily and well about the particular individual hypotheses that underlie a concrete piece of current research, They are little better than laymen at characterizing the established bases of their field, its legitimate problems and methods. That is, the scientists themselves can't tell you a set of rules they're following. They're clearly all kind of doing the same thing. They're on the same page. There's this consensus, or on page 11, Kuhn actually calls it an apparent consensus, right? It's an apparent consensus, again, because actually it may turn out that they don't really agree about some important things. But as long as normal science continues, that's covered over. And it's covered over because um, um, they're not engaged in doing something for rational reasons of methodology that they can tell you. And Kuhn says, even when you look and try to find the rules that they're implicitly following, the more you look, the harder it becomes. That's just his report of his own experience, at least, I guess. Um, so, what are they doing? Um, um, it's not a rational activity at all. It's the opposite of what Popper would tell you you would find. They're not, there's certain things that they're doing and they can't tell you why, but it's because that's the way they were trained. And that's the way everyone was trained. Um, and Kuhn says at one point that training in science is more rigid than almost any other field, except possibly with the exception of Orthodox theology. So, and I mean, um, it certainly is true that if you're in a science course and you start questioning basic assumptions, um, that's not going to be taken well. Um, I mean, I remember when I was a freshman, and this was probably an early sign that I shouldn't be trying to go into astrophysics, but it took me a long time to figure that out. But I remember as a freshman in physics classes that I was doing exactly that, asking, but wait a second, what justifies this approximation? And and at one point, a TA actually said to me, if you're going to keep asking questions like this, you should not be going to physics. Right. So yeah, it's definitely true. Um, and it's definitely true. I think it's true. So my experience is it's true that um, scientists don't usually make very good philosophers of science. Um, uh, I mean, again, that was part of what I said was the difference between modern science and Aristotelian science at the beginning of the course, right? That in Aristotelian, if you were an expert in Aristotelian physics, above all, you would have to be an expert in saying what physics is. What science is it? That's the first thing you had to know. But to be a current physicist, if you're interested in that at all, it's a side interest. It's not part of your professional work. So, and uh, I mean, this doesn't necessarily mean that Kuhn's explanation for this is right. In fact, I don't think it is, but um, Kuhn's explanation certainly would work, right? Why is it that scientists can't explain to you the rational basis for what they're doing? Why is it that they don't encourage critical questions of the fundamental assumptions? Um, Answer, they're not doing anything rational. They don't want those assumptions questioned. That's the last thing they want. Um, and and that is what Kuhn calls normal science. So normal science is science under a paradigm. The transition from immature science to mature science, or from, I mean, sometimes he says the immature sciences aren't really sciences yet, from the prehistory of science to the history of the science proper. Anyway, that transition consists in the adoption of the first common paradigm. Right? He says that in the pre-paradigm period, each of the schools has something like its own paradigm, but because they don't have one in common, they don't get these benefits out of it, right? They spend all their time defending their paradigm against the others. Um, um, okay, and now I think, right, so yeah, that mature science means getting your first paradigm, and once you have a paradigm, you're doing normal science. And normal science again means, now I haven't said what normal scientists do yet, and I better say that quickly because I'm going to run out of time. But but what they don't do is try to challenge, try to find fundamental novelties, as Kuhn puts it. They're not in search of that. They don't want them, and they're intolerant of them if other people propose them, either theoretical or observational. And so I think now you can see why I say that, at least from a Popperian point of view, the radical thing about this book is the description of normal science. That's the anti-Popperian part. And I think it really is the most radical part of the point book, period. Later, he's going to talk about scientific revolutions when the paradigm changes. But I think the main point of that is just to show it's what Kuhn would call a mopping up operation, which apparently is a military metaphor. It comes from like bombing terminology. At least that's what I read. I don't know if it's true. But in any case, it's a mopping up operation. It's just to show that at this time, when you might think the scientists, now at last they kind of wake up and question their fundamental assumptions and do what Popper says they should do. Kuhn wants to describe how a scientific revolution works in a way that closes that off. That no, even then they're not doing it. And it's one more thing before I say something about the activities of normal science. Well, no, maybe I shouldn't say a lot about that in detail. No, maybe I should, but before I say that, I should discuss puzzle solving. So, um, right, so normal science, the way we discovered it. So, what is it aimed at? So it's not aimed at discovering fundamental novelty. It's not aimed at being useful, Kuhn says. Right? Kuhn says that again, it's the immature sciences where, or sciences more close to practice, like medicine, that are always being bombarded with the demand that they answer a certain question, whether they have techniques, recognized techniques for addressing it or not, whether or not there's any indication that this problem can be solved. Whereas, right, so like, tell us how to achieve world peace. I don't know which particular science he would ask that about, but sociology, quote unquote political science, something like that. I don't know. And the thing is, like, you're not allowed to say, oh, that problem's too hard. I prefer to work on this. Or if there's a part of political science, and I guess there are, where people work on like voting behaviors or something, where you are allowed to say that, Kuhn would say, well, that's at least a step towards becoming a mature science, right? We're not addressing the big questions that people really want to know the answer to. We're addressing the questions that the paradigm tells us are worth investigating. And the paradigm tells us they're worth investigating because the paradigm, number one, greatly restricts what the answer could be. Right? Kuhn says the range of acceptable, this is at page 35, the range of acceptable results is small compared to, quote, what imagination can conceive. If you just like started thinking, what might happen when I turn this dial on this machine, it could be anything, right? But the paradigm leads you to expect that it's going to be, it leads you to a very specific expectation of what's going to happen. It's just, there's a little bit of leeway left. And that's what you're trying to fill in. That's part of the activity that Kuhn calls articulation of theory. Right? The articulation of the theory means that the paradigm theory, which again is only part of the paradigm, but it is part of the paradigm, or theory or theories. There are certain theories that we all agree on without questioning, but they aren't sufficiently articulated. Now, I guess articulated, I'm not sure why articulated should mean this. Articulated really means having joints, but I guess but anyway, what he means by it is like that there's more than one way we can imagine subsuming certain phenomena under the paradigm. More than one way they might fit into the boxes we have available. Um, and so we want to determine which way. We believe in the paradigm, so we know one of the ways is right, but we're not sure which. Or oftentimes we feel like it has to be within this numerical range, but we're not sure where. Um, 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 so as Kuhn puts it, like we're looking for the least significant part, right? That is, we already know almost everything about what's going to happen. We're just looking for some details. Sometimes that means just measuring a constant of nature more accurately, right? Like, what is the electron mass exactly? Something like that. Or what is the universal gravitational constant? Um, Sometimes it's a little more open-ended than that, but not much. Um, you know, we don't know exactly how to extend quantum mechanics to some new kind of force. So we have to play with different ways of doing it. But we know it has to look like a quantum mechanical theory, so that really restricts what what alternatives we could consider. Those are the type of examples we're talking about. So the question is, why do that? So here I did talk about at least part of what Kuhn says the the actual activities of normal scientists are. And maybe I should just say the other ones. He says there's only three. Um, uh, One of them is trying to fit the theory better to the data. Um, One of them is trying to get new predictions out of the theory. And one of them is articulation of theory. I think I said that right. I didn't write those down in my notes. So the question is like, and again, all three of those, you're not necessarily getting, you're not learning anything novel, right? Because the whole point is to show that the theory you have is working. Determine, or actually not to show that it's working, but to determine exactly how it works, knowing in advance that it will work. Um, and it's what you end up like investigating. There's no reason to believe it will be useful because it will be selected by what areas it's easy to get predictions out of the theory in, for example. Um, and Kuhn says if you actually do find something useful that has to be done over and over again, like calculate the times of sunrise and sunset or something like that. So scientists like hive that off to someone else. That's not science. So why do this? Um, I mean, Kuhn admits, although it's gonna, in the end, it's gonna be hard to explain based on his picture of science why this would be. But Kuhn says, yeah, it's true. In the long run, science sometimes proves useful. Um, and yes, in the long run, it does something that can be described as discovering novelties. Although we'll find that when we actually see what a revolution does, we'll see that that description is kind of funny. Um, but if that's what drew you into science, and Kuhn says that is what often draws people into science, motives like that. Um, what you actually end up doing has no relation to that, right? It's not helping anyone. It's not discovering new fundamental truths about the world. And I believe this is what Kuhn did in his own doctoral dissertation. I think his doctoral dissertation was focused on measuring certain spectral lines more accurately. So he's speaking from experience. He says, you may be frustrated and disappointed, and you might be prompted to leave science, which what he did. But obviously, not everyone leaves science. They stay in. Why are they still doing it? So, I mean, it's like this is another big question about the book. Does Kuhn think you should do this? He didn't keep doing it. And a lot of times he describes science in terms that makes it sound very unattractive, right? It's oppressive, it's rigid, et cetera, et cetera. Um, um, but later on, at least, he denied that that's what he meant to say. So we'll have to talk about that again later. But the point is, um, we have a mystery according to Kuhn's view of science, which is why scientists do it. And Kuhn says it's because of it's because what they're doing is puzzle solving. That is normal science. This really doesn't belong in between, right? Normal science is puzzle solving according to a paradigm. What does he mean by puzzle solving? He actually says when he introduces this, you might think this is a metaphor, but he says, no, according to the commonly understood meaning of puzzle, What scientists are doing is solving puzzles. So, what is solving a puzzle? Solving a puzzle means, um, number one, there's guaranteed to be a solution, right? Oftentimes, when you buy a jigsaw puzzle, they actually have a picture of the solution on the cover. So, you know what you're going to get. You just don't know exactly how to get there. And so, what you discover, so to speak, or uncover is something about your own skill, right? It's a test of your skill. And there's certain rules. And this is where Kuhn says it's, of course, they're not exactly like the rules of a jigsaw puzzle. The rules of a jigsaw puzzle, even though I guess it's true that jigsaw puzzle solvers don't normally think about them and might even have a hard time listing them, right? Kuhn lists some of them, like the pieces all have to be right side up. Uh, you can't force them. There can't be any holes left, right? Um, so, uh, um, but maybe you could, without too much trouble, list all of the rules of jigsaw puzzle solving. So science is not like that. We don't have rules that we can necessarily list. There's a paradigm rather than a set of rules. There are some rules you can list, but they don't go far enough, basically. But I mean, but nevertheless, there's a recognized way of doing it, right? So like there's a solution, what roughly speaking you're allowed to do to try to get the solution. And the only question is, are you skillful enough to do it? And if you don't get an answer within the range you were expecting, almost always, except when the paradigm somehow becomes in trouble, almost always, that's a sign that your experiment failed, right? That is, you weren't skillful enough to get the right answer. Um, so Kuhn says this is puzzle solving, and we know people become addicted to puzzle solving, and that's what's going on. The reason people devote their lives to this is the same reason people devote their lives to solving crossword puzzles or whatever, or at least spend much more of their lives than they should on solving crossword puzzles. And if they could get the government to support them with a grant to do nothing but solve crossword puzzles, they would. Somehow, the scientists, this is another question, how? What's going on here? Somehow the scientists convinced the government to support them. Government, students, all kinds of people to pay them to solve these puzzles all the time. And they like it because when they do solve the puzzle, they've shown their skill. But again, addiction is not really an attractive way to describe an activity, right? It implies that science, whereas for Popper, science is the paradigm, using it in the pre-Kuhn sense, science is the paradigm of a free rational activity. In Kuhn, it's an addictive activity that people only keep doing because they um, to call something addictive, I think, is to say that the motive is not one that the person themselves would recognize as a good motive, basically. Right? They have to not think about it, essentially, to keep doing it. Um, they can't break out of it. Um, uh, because the way they got into it is by suppressing the question about motive, something like that. So, um, so basically, I mean, from Kuhn's point of view, although it may be that science is useful on the whole, although again, it's going to be hard. We'll see it's going to be hard to explain why. I mean, Popper also had a problem with that, of course. It's going to be hard to explain, but maybe science on the whole could be useful. Um, but it looks like it's useful in an impermissible way. Let's say from the point of view of Kantian ethics, right? The scientists have been duped into doing it. We dangled these motivations that they really cared about in front of them until they got addicted to puzzle solving, and we let them keep doing it. In other words, scientists are being used as means rather than ends in this activity, rather than also as ends, to give the correct form of the categorical imperative. Um, okay, so there's a couple more things I could say, but I'm out of time. So I will see you on Tuesday. I hope people will turn up on Tuesday, even though I know it's right before Thanksgiving. I'm gonna come. Uh, so I hope some people will be there. Okay, and I will see you then. Bye.